We now prove that this equation is a trigonometric identity. So first, let me consider the left-hand side expression, and this equals cosine of alpha plus beta over sine of alpha minus beta. And in the next step, I'm going to expand this cosine of alpha plus beta using the sum formula for cosine function as well as the difference formula for sine function. So according to the sum formula for cosine function, cosine of alpha plus beta can be written as cosine alpha cosine beta minus sine alpha sine beta, and this is all over. Now I expand the sine of alpha minus beta using the difference formula for sine alpha minus beta. So therefore this can be written as sine alpha cosine beta minus cosine alpha sine beta. And now in the next step, I'm going to divide both the numerator and denominator by cosine alpha cosine beta. So I write this as cosine alpha cosine beta minus sine alpha sine beta. So I divide this by cosine alpha cosine beta. This is the numerator part, and this is all over the denominator part. It is sine alpha cosine beta minus cosine alpha sine beta, and this also we divide by the same factor, that is cosine alpha cosine beta. Now we can rewrite this both the numerator and denominator fraction as a difference of two terms. That is, we rewrite this as this will be one term and this will be another term. Okay, so let me write this. That is cosine alpha cosine beta. This is over cosine alpha cosine beta minus sine alpha sine beta over cosine alpha cosine beta. This is the numerator part. Now this is all over the denominator part. Also we split this as two fractions. That is sine alpha cosine beta over cosine alpha cosine beta minus cosine alpha sine beta over cosine alpha cosine beta. Now we can do some cancellations. That is, this one is cosine alpha cosine beta over cosine alpha cosine beta. This equals 1. So I put 1 here. And here we see that we can use the reciprocal identity. That is sine x over cosine x. This equals tangent x. Actually, this is a quotient identity. I'm going to use this one. So now we see that we have sine alpha by cosine alpha. This equals tan alpha. And similarly, sine beta over cosine beta. This is written as tangent beta. So let me write that here. Therefore, the numerator becomes in fact, I can also simplify the denominator as like this. So here we have sine alpha over cosine alpha. This is tangent alpha, and cos beta, these two gets cancelled. And here cos alpha are getting cancelled. And then we have sine beta over cosine beta, and this equals tan beta. So let me put this now. So therefore, we have numerator, we have 1 minus of tan alpha tan beta, and this is over the denominator. We have tan alpha minus tan beta, and according to the given equation, this is the right hand side expression. So therefore, we see that left side expression equals right side expression, and this means this equation is a trigonometric identity.